It's 7 o'clock, so it's time for us to begin. Thank you, everyone, very much for joining us. Welcome to the BCS Sussex Branch monthly meeting. This is one of the rather more special meetings in the year, and it's one I particularly look forward to. It's the talks by our student prize winners. It's I'm always surprised by this one. I'm never entirely sure what to expect by the diversity, by the kind of skill and the interest, you know, just how interesting and really progressive and kind of, yeah, these talks are. So I don't mean to put a whole load of pressure on our speakers. I'm sure they are looking at these topics. There's already a lot I'm really interested to hear more about. So this particular today, we are in the branch, we support both students from the University of Sussex and the University of Brighton. Today is all students from the University of Sussex School of Engineering and Informatics. So thank you all very much for joining us, and thank you for the school for its support of this work and working with us. So today our prize winners, we're going to have talks from Alberta Sandito on using dynamic knowledge graph for fake news early detection. From Sam Holgate on comparing the scalability of a microservice-based and a monolithic web application. Namho Ko on Vidirex, a navigational application inspired by ants. Aidan Valentine, who is going to talk about simulating large constellations of satellite networks. And finally, Marion Laname, sorry, I probably mispronounced your name. You can correct me later, for his project Attendance Pro, attendance monitoring and visualization software. So each student will be speaking in total for around 10 minutes, and there will be a chance to ask any questions at the end of their presentation. So I'd be really grateful if you could kind of hold off and share your questions, though you can share them in the chat beforehand, but we can then open the floor to discuss them. As we have 5 students today, we actually have quite a lot to get through. So it's, but there will be a chance to ask questions at the end, and we will also hopefully have a bit of time for a broader discussion with everyone at the end if you would like to stay on. I think it's time to begin, unless anyone else has anything they would like to add before we move into the talks. Great, I'll take that as a no. So I will hand over to Albertus on his project of using dynamic knowledge graph for fake news early detection. So over to you.
Thank you, Matthew. So let me just share my screen. Okay, good evening, everyone. My name is Albertus, and my final year project was about using dynamic knowledge graph for fake news early detection. So as we all know, right now fake news is everywhere. They have been propagated widely and rapidly, either intentionally or unintentionally. And actually, detecting fake news is made more difficult because of one of the aspects of news itself, which is news timeliness, where at one time a certain fact can be true, but the next day probably the same fact can be false, or vice versa. And there have been many approaches in fake news detection, either manually or automatic, maybe ones that depends on the propagation pattern of the fake news, or another that depends on the writing style of the fake news. However, these methods haven't really incorporated the news timeliness aspect. So actually it makes sense for a fake news detection system to rely on the content of the news only. So this type of method is called the knowledge-based fake news detection. And with this, we can detect fake news at an early stage before they are being propagated widely. So essentially, in a knowledge-based method, there is a collection of facts that is used as a ground truth. So in this project specifically, the collection of facts is coming from the knowledge that is extracted from trusted news websites such as the BBC or The Guardian, And then there's of course the to be verified article, which is then fact check against the collection of facts. So there are actually many challenges in building such system. The system needs to be able to extract the high quality triples, which is the representation of knowledge in this project. The system also needs to keep the knowledge base or the knowledge graph updated all the time, which makes it dynamic. And it also needs to deal with conflicting triples and finding non-exact matches when fact checking. So realizing that these challenges are difficult, I decided early on to make this project, to make the system semi-automated rather than fully automated. So I mentioned a bit about triple. So a triple or a semantic triple is basically a construct of subject, relation, and object. So for example, from the sentence, John Doe ignored social distancing, we can get the John Doe as the subject, ignore as the relation, and social distancing as the object. So this is a single triple. When we have a collection of triples, we call it a knowledge graph. As I've mentioned before, in this project, the knowledge graph is built from triples that are extracted from trusted news articles. However, it might lead to an incomplete knowledge graph, which is why also in this project, I use DBpedia as the knowledge graph in the background, as the base knowledge graph. So DBpedia is an open knowledge graph that is based on Wikipedia. So talking about the implementation a bit now, this is the high-level system architecture diagram. So on the top left, we can see the trusted news articles are being scraped by the web scraper periodically, and they are being saved in the database. And then we have this component, knowledge graph updater, which extract the triples from the articles that are saved either on demand or automatically. And then the triples are added or removed from or to the knowledge graph. And then the other component fact checker will obviously fact check the to be verified facts by querying the knowledge graph to see whether they are matched or not. And from the user perspective, the user can either submit a new fact to be included in the knowledge graph, or to submit to be verified news articles to be fact checked. This is done through the user interface, which calls the REST API and in turn calls the respective components. And these are the tech stack that I use in this project. I didn't prepare any demo for this, but let me just show you some screenshots on one of the feature of the system, which is the fact checking. So for example, let's say we want to fact check these sentences. John Doe neglected social distancing. He was admitted to hospital on Sunday because he contracted coronavirus. So when we click the fact check button, it will come up with results in 4 different categories. The first one would be the exact matches. So for example, from the sentence here, we can get the triple being extracted is John Doe admit hospital. Why is this an exact match? Why is this an exact match? In this specific scenario, this is because in the knowledge graph, there already exists the same exact triple, John Doe admit hospital, which means that this is a true triple, this is known to the knowledge graph, and this is an exact match. The second category would be the possible matches. From the sentence, we get the triple, John Doe neglects social distancing. Why is this a possible match? So this is a possible match because in the knowledge graph, we already have the triple, John Doe ignore social distancing, not John Doe neglect social distancing. However, since ignore and neglect are synonymous, we can call them possibly true or possibly match. And the next category would be the conflicting triples. So this is where the system being semi-automated is actually really helpful. So for this specific scenario here, we can see from the sentence we get the John Doe admit Sunday. This is said to be conflicting with John Doe admit hospital. However, they're not really conflicting, right? Because from the sentence we can see that they are actually complementing each other. However, they are said to be conflicting because they have the same subject and relation. So this is where the user actually needs to see them by themselves if the triples are conflicting or not. However, of course, if in another scenario in the knowledge graph, we already have the triple, John Doe admits Saturday, of course, then this would be true. This would be conflicting. John Doe admits Saturday and John Doe admits Sunday are conflicting to each other. And the last category would be the unknown triples. So from the sentence, we get the triple John Doe contract coronavirus, and we haven't seen this triple at all in the knowledge graph, which means this is unknown. But if the user knows exactly that this is actually true, then they can, same as the conflicting triples, they can add this triple to the knowledge graph for future uses. So I evaluated this project, the system with several ways actually. So the first one would be by evaluating the triple quality, the extracted triple quality. So I submitted around like 25 news articles to the system, and it got like 706 triples, where more than half of them are expected, which means that they are of good quality. However, the rest are what I call erroneous, and most of them are erroneous because of the failing coreference resolution. So what do I mean by this? So let's take an example from the sentences. If we do a coreference resolution, the sentences will be transformed into John Doe neglected social distancing. John Doe was admitted to hospital on Sunday because John Doe contracted coronavirus. It turns out that the coreference resolution tool that I'm using is not entirely perfect, which leads to a lot of low quality triples. And actually, the quality of triples is affecting the fact-checking performance itself by quite a lot. So I also evaluated the result of the fact-checking performance. And this is done by fact-checking articles of the same topics from different news sources to see if there are many overlaps or not. And turns out that the possible matches has a low recall, which suggests that many of the triples should have had possible matches, but they didn't have any at all. And from further investigation can be seen that actually the triple quality affects a lot of the performance. So to conclude, from this project, we can see that dynamic knowledge graph can be utilized to do early fact-checking, and the quality of triples is in line with the fact-checking performance, which means that if we want to have a good performance of the fact-checking, we also need to have a good quality of triples. And coreference resolution is important to get good quality triples. And finally, this project is a step towards fully automated early fact-checking. That is all from me. Thank you.
Thank you very much, Albertus. That's fascinating. I like the implications of this approach and this technology are really quite exciting beyond just fact checking. So yeah, fantastic. Does anyone have any questions briefly about this project before we move on to the next one? Okay, James, yeah. Oh, we've got Ian, yeah. By all means, either ask in the chat or just stick your hand up or start talking, whichever.
Thank you, Matthew. Albertus, thank you very much for your talk. That was great. Well done and congratulations. Just a general question in terms of this automated. You say it was semi-automated. To what extent can you perceive that this could be more automatic, if you like? You can increase the amount of automation in this process, or is this something that's, if you like, you can't go beyond what you've done in this project?
Yes, one way is probably to get this part here fully automated. So as I said previously, the user really needs to check themselves whether certain triples are conflicting or possible or not. So there's not much of a high confidence here. However, if in the future, then that part can be automated by making the performance of the fact checking itself better. Then that is the fully automated part.
Thank you. And just a quick question, very quickly. Did you consider fact checking your report?
No, I have not. No.
Thank you very much.
Cool. Does anyone else have anything they'd like to add before we move on to the next one? It'll have to be a fairly quick question because we're quite a lot to fit in today. Yeah, James?
Great project. Just wanted to ask, particularly that part where you looked at the relations and the synonyms. Did you use something like WordNet or a corpus to determine the synonyms, or did you have a boundary that you decided on for what would constitute a synonym?
Yes, like you've said, actually, yeah, I use WordNet here. So it's simply just looking at the synonyms using WordNet.
Great. And maybe one quick thing, when you said co-referencing, something we've recently done at my company is use the Allen NLP implementation, which we found was an improvement, and then combined that with a wiki split train T5 model that will split long sentences up, and that massively improved performance for us. So just in case it's helpful.
Thank you for your suggestion.
Oh, wonderful stuff. Well, thank you very much, Albertus. So we will now move on to the next talk, which is Sam talking about the comparing the scalability of a microservice-based and monolithic web application.
Yes, hiya. Let me just share those slides. Firstly, while I'm getting the slides up, is there bad background noise? My neighbors are being really noisy.
It's fine, fine from my perspective.
Okay, excellent. Well, then we're in luck. Okay, hi. I'm going to breeze over a lot of the content a bit so that I've got time for questions at the end. So I'm very happy to kind of wheel back to the slides at the end if there are bits people would like to hear a bit more about. But yeah, thanks a lot for this opportunity to share my project with you. So quick, probably very unnecessary definitions, but by scalability, I'm just kind of talking about the ease with which I can add additional resource to an application as it grows. Microservices, I'm talking about the modern distributed pattern where you can compose an application with a set of smaller applications, and this contrasts with monoliths, which are the more traditional approach where instead that application would just be one application. So yeah, with that out of the way, why did I do this? During an internship at American Express, I encountered the microservices pattern, but because this was part of an existing project, there were loads of pre-built components and kind of little spring starters. But this just meant there was absolutely tons of magic code that like no one seemed to care about, that there was this magic. And I really hate the magic code that no one knows how or why it works. I'm a stickler for knowing how it works if I want to use it. So I was really keen to try and develop using this approach myself, using this tool set myself. And the final year project seemed like a really good opportunity to try and develop a scalable application using this approach. So I needed some business logic if I was going to build a backend for something, I needed an application. So I actually merged with one of the proposed projects from the database that was about creating a platform that would enable mass competition at table tennis. I then generalized it to just 1 versus 1 games because it didn't really have any effect and just increased the potential for the project. So by this, what we mean is that players of any game can report the outcomes of their games to the server, and then the server can use their match performances to calculate ratings for the players and then rank them on leaderboards, like how you have for chess ratings, like the ELO rating system, which is what I actually then used as the rating system under the hood. So with this, I found my system architecture. So I divided it into 3 microservices. I have the lobby manager that's responsible for dealing with games in progress. So it's responsible for ensuring that consensus is reached when people report the outcomes. There's also the authenticator, which deals with both authentication and authorization. And then finally, the leaderboard manager, which performs the calculations to calculate the ratings, and it also persists the ratings as well as the outcomes. So, oh yeah, and I had a reactive stack, but again, I'll wheel back if anyone's interested later on. So I realized that if I'd like to actually kind of put my money where my mouth is and have any evidence of this purported scalability, it would be really useful to have something to compare against. So I decided to combine flatten the code bases of the 3 microservices into a kind of monolithic version that would then be able to, I could then compare the performance of the 2 relative to each other to kind of try and gain some insight into the scalability. So I didn't need to have any kind of REST calls between the services or anything, just direct reactive calls. So I used Apache JMeter to and created a test script where 2 users would sign up and log in. 1 user would invite the other to a lobby, which the other would accept. They'd then fire some number of proposed results to see, you know, in case there's some discrepancy, and ultimately one of them would confirm the result, and that would be that. And I was hoping / expecting that that the monolith would outperform at low loads, because there's, you know, it's all in one system. There's no REST calls or anything, but that the microservices would overtake because the decline in performance would be more pronounced in the monolith as load grew, as it began to get overwhelmed. And that also, as so many of the request types required some authorization check, that the authenticator would end up taking the heaviest brunt of the load effectively. So my findings, fortunately, supported this, and at low load, which is here, 500 concurrent users, the monolith, the gray bar, outperformed by about 1,200 requests per second, not quite that good, versus about 800, 900. And that once it reached around 2,500 concurrent users here, the microservices just edged ahead. And once the concurrent user count was as high as 5,000, frankly, they started grinding to a halt, and they weren't really worth using. But I also just fiddled with deploying the authenticator separately to effectively just allocate more resources. And this had an enormous effect at low concurrent user counts, but again, diminished as the count raised and started having timeouts at 5,000. So that's something that I would really quite like to look into if I were to kind of spend any more time looking at this. So yeah, I've kind of whizzed through that quite fast, but I've got, yeah, these are just CPU profiling from each of them. So this top left pair are the authenticator at 1250 concurrent users and 5,000. And so this is the authenticator, this is the leaderboard manager, this is the lobby manager, and this is the mini monolith, just as the kind of control baseline. And you can see how disproportionately the authenticator received all of the load. So I would kind of probably scale those behind a load balancer with some kind of elastic scaling to allocate more resource as it improved. Yeah, I've plowed through that a little bit, but yeah, please, questions.
That's great. Thank you very much, Sam. And I really enjoy how, you know, we've gone from something really, this is just a practical project, you know, and it's actually something I'm literally looking into at the moment myself for an implementation. So I think it's really, really good. And I think it's, if I can just add a quick kind of comment, I think it's really nice to see just microservices demonstrated just in terms of pure performance as an advantage, instead of just all of the other advantages that you can get from splitting things up. So yeah, so I think it's a really fascinating one. Does anyone have any questions for Sam?
Did you run into any race conditions or problems as you started to scale out the microservices?
So I didn't end up getting to full deployment and with the actual scaling with load balancing. So this was, I had to kind of control it. This was largely a same host deployment because the idea to do the comparison was about a month before the deadline. So I suddenly kind of doubled my workload, and yeah, it wasn't factored into my time plan.
No worries, thank you.
I'd just like to say, Sam, great piece of work, well done.
Thank you.
Great stuff. Do you have any plans to develop it further, this kind of stuff, these metrics or anything like that?
Yeah, so oh, I've actually skipped a slide, but yeah, I'm hoping to kind of do a little bit more of it over summer before I kind of start working. So hopefully watch this space. You never know. But yeah, if anyone's interested, please feel free to email me and I can explain anything else.
Great. Cool.
Could you explain briefly how you coupled everything together to remove the presumably REST interfaces and produce your monolith? Was that a programmed operation, or did you just hack the source?
It was actually quite painless because I was using Spring Boot. I was using Spring Web Flux. I was able to just use the no, it was Project Reactor. The reactive calls, the pipelines. I was able to replace where it before had been a REST call. I could just instead make a reactive call to the actual object.
Oh, very good. Yeah, wonderful.
It was quite painless.
Great answer.
Very neat. Nice. So if no one else has any burning questions for Sam, then we'll move on to the next project. So next project is Namho talking about Vidirex, a navigational application inspired by ants. And before he begins, I just want to add how that he is joining us. It is 3:30 in the morning where you are, Namho, which I think is really showing some real dedication to appearing. So thank you very much simply for doing that, and I'll hand over to you now.
No, it's completely my pleasure. And let me just set up the screen share. Yeah. There you go. Can everyone see? Awesome. First of all, thank you so much for your time today. And it is my delight to share with you today my final year project, which is Vidirex, a navigation application inspired by ants as part of my final year project. And so the structure of the talk is as follows. So I'll first discuss briefly the motivation behind the project itself, then briefly into insect-inspired navigation, as well as a brief overview of the application implementation. And then lastly, a part where I discuss the future workings and time for question and answers. So most of our lives, we take vision for granted when we're sighted. So if you think about it, if you want to navigate within a familiar space, sighted is pretty easy to do. However, that becomes an immense challenge with the visually impaired and blind. And so as it currently stands, there are about 285 million visually impaired in the world, 39 million who are blind, and 246 million who have low vision as of 2010. However, luckily, there are various solutions out there that augment the navigation experiences for the BVI users. For instance, you have the long cane. And so with the long cane, it does provide adequate surface level information. However, it does induce embarrassing reaching behaviors and does not provide protection upwards to the torso. And then one of them, another prevalent solution out there is with guide dogs. However, with guide dogs, it is quite expensive and unfortunately not widely accepted in many countries such as South Korea. And there's a high likelihood of poor interplay between the user. And the next, a more somewhat reliable and firm guide would be a sighted guide. And that refers to a person who is physically next to you and guides you in your everyday life throughout your journey. However, this is also very costly and does require significant trust to be established in the long run. And lastly, one of the most scalable solutions out there and being developed is with GPS-based solutions. And so with GPS-based solutions, you get accurate headings and accurate navigational information outdoors. However, it does suffer indoors, and as well as suffering within 300 meters. And battery life is always a dependency with GPS. And so given all these solutions, how could we potentially guide a blind and vision impaired user through an indoor space that requires not only accurate cues, but also accurate signaling within an indoor space? So in order to do so, I first wanted to reach out to actual BVI users and really try to build a true empathy behind their struggles, but also discuss their shared experiences with the various solutions out there. And I was lucky enough and fortunate enough to chat with 2 people specifically. And then given that, and with supported literature, I was able to create a word map about the struggles they face, but also the various solutions they tried, and also the pros and cons for each, and also their struggles with indoor navigation, as well as the various ideas they have with somewhat like an ideal app they want developed in a way. And so given all this, what could be done? So the basis of the project is to combine the ingenuity of insect navigation and combine that with the edge computing capacity of mobile devices, and then to produce a robust solution. And so the main advantage of utilizing instinct models is that they only require low resolution images, and that's always favorable in terms of computing for memory and as well as just computational resources. And so now I'll just briefly go over instinct-inspired navigation due to time, but specifically with ant navigation. And so one of the great popular navigators in nature are with desert ants, especially with forager ants. And so they utilize various methods of navigation, such as path integration with counting the steps, utilizing visual guidance, as well as idiothetic cues. And so one of the most prevalent models out there is by utilizing what we call a snapshot model. And so briefly overviewing what a snapshot model is that by utilizing a single view of the world, it's memorized from a specific goal location, it is able to minimize the difference between its stored view and its current view to approach towards the goal. Although this does work with a single, within the vicinity of the goal, it does not extend well into long distances, as well as we have limited landmarks, such as in the desert. And so the research conducted at Sussex extended this model into longer range distances by representing a model of ant route navigation driven by scene familiarity. And so by utilizing a panoramic image as a visual compass, while the ant can perform learning walks from the nest to the feeding ground. And then by storing the images in memory, it is able to navigate from its nest to a feeding ground with more images in its memory, and thus extending it to longer routes. And so this can be thus visualized into somewhat what we call a visual compass. So by translating this similar action into a user's perspective, a user would essentially train through a route. And then once the route is trained, the frames of each step will be extracted. And then at each step, when they're traversing through the route, the images in memory will be compared against the ones that they're seeing in the rotational view. And so a panoramic image, obviously it's in 360 degrees. However, given that I wanted the application to be used without any additional hardware as possible, I opted into 120 degrees, which is what's commonly available into the wide angle camera lenses and smartphones nowadays. And so by doing the scan, you're able to identify which heading is the most familiar and least different to what you see in memory. Then that would be the distance you would, the trajectory you would move towards to. And so the actual application implementation involved, well, first doing some offline testing, as well as tuning the algorithm to see how it works in non-urban environments. And so this is a brief RIDF graph that I was discussing before. And so simply it's by computing the goal image and a current view image here, and then you produce a difference image. And where you see the steep drop is where the image matches perfectly. And it is important to note that this doesn't occur in nature as always, like you don't get that perfect match, but for testing reasons, it's good to see that it works within the environment you see. So I extended this testing through different routes outside. And then I wanted to measure how the distribution of error occurs as you deviate away from the central position where you train the route. And by doing so, luckily, we are able to see that even if the user is displaced from the initial position where they train the route, it is within acceptable distances, as well as being able to traverse the route without any issues. And so now with the application implementation, the application is currently available on Android devices. And the main reason being so is because it does provide greater access to developer settings, as well as more allowance on like adding models and deploying models on it. And so with the application development, it was with fulfilling the different requirements, as well as delivering an MVP product towards the end. And before entering the whole frameworks that I used, it is important to note that behind everything in the project itself, it's based upon accessibility. And so accessibility simply refers to the fact that even if you're cognitively disabled, even maybe impairments with dexterity, that no impairments would actually limit yourself by gaining access to different technologies and applications. So given that the whole core of the application is based upon with accessibility in mind. And so I'll just briefly go over the different frameworks I use. And as I mentioned, Android Studios, then I utilize a TensorFlow language model to simply deploy a on-device NLU system. And so it provides a greater interaction, a hands-free interaction with the user. And next, natural choice was OpenCV, being one of the most popular known image processing libraries on device. And lastly, using Firebase, which is Google's real-time database. And by using Firebase, it allowed me to actually store the routes on the cloud where users can access them on any device, actually. So once the application development was in hand, one of the most important sections, obviously, with any project would be the evaluation and testing. And for me, it was mostly being able to deploy this app in nature as well as indoors, and then assessing the feasibility of the system as well as the usability, and then just investigating whether there's any improvements that could be done. And so I trained 2 routes, indoors and outdoors. And due to the interest of time, I'll just skip through the videos and then comment on them. And so as you can see, the user will have to initially step through the route. So I'm currently going from one side to the elevator as to the entrance. And so once the route has been stepped through, as we call a learning walk, then the user is able to store the route as such. Then you name the route, and then you'd be extracting frames from the video. And once the frames have been extracted, those becomes the images you use in memory to compare against your current view to move towards to. And so the user is notified by an auditory signal. And so as you can see on the bottom right, the graph where as the graph peaks, that's where the difference is the highest, and then the lowest is the difference is the lowest. And then the user is notified by sound. And I'm testing the route blindfolded. And I'll discuss the various limitations and the outcomes later, but I almost did hit the wall, but it does show that you're able to get from a place to another just through by using the application itself. And so then I extended that to a longer route outside. And these videos are on YouTube, so you'll be able to watch them in the full length with all the descriptions and everything. And so I'm training through from one side to the entrance of the apartment. Then I follow the same steps of storing the route and then extracting the frames. And then in the actual stepping of the route, I'm scanning the environment. And then at each time when I'm scanning it, well, the application is computing which direction is actually the least different. And then I'm moving towards it. And so the application does work, and it does provide adequate enough information to move towards the correct heading. However, it does require more robust testing as well as better signaling to the user. And it is noted that the application does suffer with repeating patterns in the environment. And so one of the solutions that could be implemented is not using the repeating patterns, or maybe not including them in the actual computation. And so natural feature works would definitely be implementing more dynamic signaling, improving the on-device NLU model, as well as additional user testing. And lastly, I just wanted to end this talk with a very humbling experience with a guide actually, to truly see what it would be like in a BVI's user's perspective into navigating in the world actually. And so that just builds into the entire empathy of the project. And so thank you so much for your time today, and I'll be happy to accept any questions. Thank you.
Wonderful. Thank you very much. First of all, I would like to say, I really, as someone who works in the accessibility field, I really admire your commitment to really actually researching and building true user empathy. I think that's a really, really important part of it. I would like to ask for really quick questions because that was a very comprehensive talk. So if anyone has anything they'd like to get into too much at the end, but if there's anything really immediate and quick, please do share it now.
Simple question, where will it go now? Is anybody taking it forward, or is it just going to sadly gather dust?
So regarding the application being useful for blind people, that is quite a difficult question to answer for now, because for an application to be at that level of reliability, it does require more testing, and has to be proven to work for blind people. But for now, I think it's going to be, ameliorating the application itself, and then developing it further so that it's more user friendly, as well as having better signaling. So that's the focus of it right now. Yeah.
Excellent. Thank you.
Yeah.
Lovely. Okay.
Could I just say again, fantastic project, great work, well done, Neville.
No, and thank you so much, and thank you.
Wonderful stuff. Okay, so yeah, hopefully we'll have a bit of a chance for any more loose ends and more detailed conversation at the end, particularly if if anyone has any follow-ups that they'd particularly like to engage with our students. So if I may, let's move on to the next talk. Our next speaker is Aidan, and he is going to talk about simulating large constellations of satellite networks. Cool. If we could change over the screen sharing, Mamho, I think you're still screen sharing. Great. Aidan's got it. Cool.
Let me just see if this works.
Yep.
Let me switch display. Can you see everyone see that okay?
Yep, working perfectly.
Okay, awesome. Right, yeah, so I'm going to talk about my final year project, which is basically simulating large constellations of satellite networks. So I'll start by giving like a little brief. So at the minute, there's quite a large amount of low Earth orbit satellites. So if anyone's heard about it, the main one at the minute is Starlink, which is deployed by SpaceX, which is the aim to provide basically global high-speed internet to basically the entire Earth. If you can see on the right, there's a huge globe that's showing that's the current deployment of 1,630 satellites. They're like ignoring the polars because at the minute they're focusing on the main areas where they need internet coverage. So the features of this mainly include, so since they're satellites, these satellites can be constantly moving. So it's going to be a dynamic mesh, which is unprecedented. So it's never been done before in especially large scale is what SpaceX are trying to do. And the aim of this is to provide substantial latency reductions. So they want it to rival today's fiber and current internet, as well as provide an aggregate capacity, which is expected to reach multiple terabits per second. So they claimed in their proposal that the average round trip time is a sub 10 millisecond range between the first satellite and Earth. At the bottom right, there's some of the filing information, which is basically saying all the satellites are 550 kilometers. There was much higher, but they've reduced it to basically even further reduce the latencies. So each satellite will have inter-satellite links. These are basically laser links from each satellite. So if you see on the mesh on the right, each satellite will connect to the satellite next to each other on the same orbital plane and then the adjacent planes. The reason that SpaceX want to do this and other companies is because these lasers are not limited by glass, which fiber is. They're only limited by the speed of light in the vacuum, which is quite a lot faster than fiber. And obviously the ground stations can't have these laser beams, so they'll be using radio frequency waves, which are phased array. But these are slightly not as good as laser, as they have to go through the Earth's atmosphere. But these are the primary communication method at the moment, because inter-satellite links have proven to be quite a hard technology to get down. So it's quite slow to get the inter-satellite link deployment in, and there's only very few being deployed. But that's why it's important for the project, as I get on in a minute. This is just showing a really simple 10% coverage of the constellation. So as said before, they're prioritizing areas where the internet is mostly needed. So if you see, Europe has got quite a lot of coverage, as well as America, and areas such as North and South Poles are completely ignored for the time being. Obviously, this is 10% of the deployment. As the later stages develop, they do plan to go across the poles as well as fill any of the gaps you see in the coverage. So the main objectives of my project was to develop a low Earth orbit satellite constellation simulation model that basically allows researchers to test and evaluate network protocols on these unprecedented networks, as they've never really been used before. So no one really knows how they're expected to work. New protocols will have to be created along the internet. And then using the simulation model, I wanted to evaluate the round trip times between the ground stations across the world, and mainly trying to reproduce results as well that existing research papers have looked at. So this is showing my simulation model here. So this is the current 1,600 satellites. If you could see like the really thin lines where there's like really clumped together satellites, they're the very few satellites have inter-satellite links. So there's not very many at the minute. My simulation model is done in a C++ network framework. And this is just strictly the mobility. I'll show you the actual routing later. So I'm going to go over like all the results and show you how I've used this simulation model to basically get an understanding on how the potential latencies and what they're like. So this is a existing paper from 2018, and they similarly created a simulation model in a Unity engine. And what they did is they tried to look at the round trip times between London and New York. If you see the line in the middle, that's Great Circle Fiber. So that's like a best case scenario where they stretch a fiber optic cable across the world. So it's not really feasible, but it's just showing a comparison. And obviously the top line here is the current internet. As shown, the inter-satellite links, the laser links that I mentioned, are far superior than all the others with ground relays. So ground relays is obviously when the ground station hops to a satellite, then back to a ground station, then back to a satellite. So it has to keep going up and down. With fewer satellites, quite a lot of variability, which can be a problem for network protocols. But overall, as the satellites increase, the variability decreases. This is my simulation model showing the routes between the exactly same scenario for ground relaying. So if you can see it starts at New York and it's hopping to a satellite and then going back down and then etc. My simulation model uses an orbital propagator. So all the satellite positions are highly accurate and it basically uses them to calculate the distances accordingly. And this is my results following that experiment. So they almost identical, they replicate the previous paper's results, further reinforcing how the constellations can benefit current internet by quite a large degree. This is another research paper, which is showing the one-way latency between Washington, DC and Frankfurt. So there's quite a bit of variability, but this is showing varying levels of deployment. And this exact paper was showing quite an outdated constellation, which Starlink are basically not even doing remotely any close anymore. But this is my simulation model showing the exact same route for inter-satellite links, where the laser links are going across a single orbital plane to reach the two destinations. Reaching quite good latency. So this is showing the results from this. So the lower satellite, so 25 to the power 2 means that there's 25 orbital planes with 25 satellites per plane. So as the satellite numbers increase, again, the variability decreases quite a lot. With the huge variability, again, can be an issue. But one really important thing that is gaining from this is you can see, because there's variability in a lot of the properties of these constellations, there's a lot of considerations network providers and network protocols need to consider. Not all, like for example, TCP won't be able to, which is the most typical data transport protocol at the minute, might not be able to cope with a lot of these characteristics. So it's important to think about all of these aspects, which is one important thing, which is part of my research, which I'm continuing. I'm hoping to research this area even further and try to figure out ways on how to develop better data transport protocols that can cope with these constellations. Yeah, and that is it. If anyone has any questions, I'll be more than happy to answer them.
Fantastic. Thank you very much, Aidan. I think it's really, really interesting to see such breadth of topics and see someone really getting into the kind of nuts and bolts of data transmission when we've had really fascinating higher level projects as well. So yeah, thank you for bringing in that variety. Does anyone have any questions they would like to ask?
This may be a bit of a mean question. Hi, Aidan. Hello
Hi,
again. But what did you take the Starlink system as a given to then build your simulation models on, or did you also consider the actual feasibility and sustainability of that whole project? Would it actually work or not? What's your opinion?
Yeah, so I built my simulation model. It can use 2 loads of data. So it can use real life satellite data as well as your own data. So you can actually dynamically create whatever constellation you want. So it's nothing relying on Starlink. This is just strictly looking at Starlink. But so far from all the experience, it is looking pretty promising. It is actually pretty cool. And Starlink have already proven they've quite a lot of, because obviously it's actually been used. You can actually buy the satellites to use Starlink right now, actually, like to put on your house, and it is actually supposed to be working as well, so which is good.
Okay, thanks.
Yeah, I have a friend who's bought one. I don't know if it works yet.
Yeah, we'll see. You know, if there are actually many users, you know, how well it holds up.
I think the point about the need to think about rethink network protocols is a really fascinating one as well. So yeah, it's,
absolutely, yes.
Yeah.
Could I just ask a quick question? So are you continuing with this work now, or are you doing? Is it something different that you're working on over the summer?
Yeah. So the summer research now, I'm continuing this at the minute. I'm currently researching a lot, like trying to get my fundamentals on data transport, and hopefully and then I want to try different transport protocols on the constellation model. So my first steps will be to test existing ones and see how they cope with the constellation, and then from this try to work out where it's going wrong, and then try to develop things from there.
It's great. Well done. Thank you very much for your talk, and congratulations.
Great, thank you. Brilliant. So if no one else has any more really burning questions for Aidan, we'll move on to the final talk, which is Marion talking about Attendance Pro, attendance monitoring and visualization software. So yeah, over to you.
Hello, let me share my screen.
Yep. Great.
So hello, my name is Marion, and I created attendance monitoring and visualization software. So firstly, I'm going to be talking about the project itself. Then I will focus about the problem that that was identified, the requirements that I set out, and then I'll do a brief software demo. So Attendance Pro is a cloud-based software system that allows universities around the UK to monitor their attendance, the attendance of their students, and the visualizations and communication tools are built straight into a web application. So the problem that most universities have is that they are not able to identify students who are struggling, and the main reason why they are struggling is because they are not attending. And the only way universities have is to extract some sort of a spreadsheet or a CSV file from their main attendance system, and then they should just kind of filter and find students. But that's not the most appropriate way to analyze student attendance. So I wanted to fix that problem, and at the beginning of the project, I definitely wanted that this system would be secure and easy to use, that there would be many levels of visualizations on the course and year level, that there would be some way to upload attendance data, and that, for example, a personal tutor or academic advisor could track specific students rather than looking at a year group or a course, and that there would be student profiles where this academic advisor could go into, and that there would be a student communication feature straight built into the application, because most applications will allow you to send one-way communication, but I wanted to have two-way communication in the application. So let's see how it looks. So currently it's being deployed to a testing environment. And so when we come to the home screen, then we are able to log in using email password or social login. So let me log in with GitHub.
We're still seeing your presentation at the moment. I don't know if that's intentional.
Okay, let me see. Can you see my screen now?
Yep, got it. Thank you.
Perfect. Okay, so yeah, so this is the home screen, which is currently deployed to a testing environment. And if I want to log in, can I press the login button and I can log in with email and password or social logins. So I'll log in with GitHub right now. And then this is the home screen that I'm presented with, which provides some basic information about like the number of students, the average attendance, a risk students, which is a term used in the application that combines both persistent absentees and students who are not attending. So not attending students are students whose attendance is 0%, and then persistent absentees are students whose attendance is 1% or above. And we can change this view between not attending students and persistent absentees. And the same thing applies here. So we can change. And below here, we've got a few more visualizations which provide information about when the absence starts in a semester and the courses which have the highest number of persistent absentees. Then in the application, we've got a mechanism to upload data. So for example, if I do this test file, which looks similar to the one that I showed earlier in the presentation, then I'm just able to check that all the details from the spreadsheet are collected correctly, and I'm able to upload it. So if I go to this students page here, then this is the tracking functionality, for example, that academic advisors could use. So currently I'm not tracking any students, but if I go to this particular student right here, then I can see specific attendance to that specific student. I'm able to enlarge those graphs and to see more granular information about that student. And I can see also their contact details and the course details. And there is this communication view, which allows a member of staff to just see all the communication history with the student. And I can send reminders as well as emails to the student, which then will be sent to the student. So go to the email, you can see that now this email was delivered and reply to that email as well. So if we go back to the profile, we can see that there is also this PDF report, which can be taken into meetings with the student and can be the basis of communications with the student. And now we can see that this email that we just sent is also tracked here. So I hope this gives a brief outline of my project. I believe this was a successful project and met most of the requirements that I set out in the first place. And this was tested by various teaching staff at Sussex. It provides monitoring tools as well as some visualizations. And it is ready to deploy to universities around the UK because it is currently deployed in a testing environment and seems to be working fine. Thank you for listening, and I'm available for any questions.
Fantastic. Thank you very much, Marion. Another really practical project, and I also admire your bravery for doing a live demo. That's always a scary thing to do.
It didn't turn out that well.
Yeah, well, it worked. So that's better than most of the ones I've ever done. Yeah. So brilliant. So does anyone have any questions around that project?
Do you anticipate integrating with any existing learning management systems at all, Marion?
That was a possibility, but that I set out, that was one of my extensions. But yeah, unfortunately, I ran out of time. But yeah, if I would have had maybe another month, that would have been definitely part of the system. Yeah.
Yeah, we hear that all the time from our developers. Thanks.
Marion, again, a great presentation, very well done. I'm sorry, Bernard, I think I jumped in front of you for this one. I just saw your hand up there. Congratulations, very well done. I've got a very quick question for you. Sometimes collecting this data is very useful for other purposes as well. For instance, if there was some kind of correlation between attendance and how well the student did, Is that something that could be incorporated into your system?
Yeah, so this was something that I initially wanted to do, but I didn't have access to great data. So, but yeah, that would be one improvement that I would like to do as well as having maybe some sort of RFID. We could use student ID cards when they come in, so it is directly, so it will be very real time, because currently it depends when the data is being uploaded, but then if you use RFID tags and student ID cards, then it would be very real time. Yeah.
Thank you very much.
Thank you. You are muted.
Well, Bernard, would you like to speak, or anyone else, or any?
Oh yes, thanks. I have a question regarding, can you compare the attendance for different modules or even different degree programs? So comparison charts, not just individual ones.
Yes, so there is a course tab as well, which I didn't show, but yes, you can filter down specific courses, and you have heat map there. So yeah, this is there. Modules, no. Because the attendance that is currently given out was only for course level. So yeah, but for instance, if I would have the module level attendance, then yeah, this would be a possibility.
Yeah, but there should be, because we obviously take a module level attendance. But anyway, that's good. I just want to take the opportunity as the project coordinator to congratulate all the students who presented today. It was really great, and I wish all the students would do as great as you did. So thanks also from my side. Thank you.
Thank you.
Yeah, thank you very much. Yeah, I'd like to second that, and really, I'm so impressed not only by the quality of the projects, but by the assured and very clear presentations all around, which is often the bigger challenge in our profession. So I really think, really impressed with everything that's been spoken about today. Some fascinating topics, really, really interesting stuff. Thank you all very, very much for sharing your projects and your time with us. So yeah, and I wish you all the best of luck in scaling them and turning them into something, getting traction with them and doing something really, really interesting with them, because they all deserve it very much. So I think we are at the top of the hour now. So what I will do is we can have some time for discussion and follow on afterwards, if anyone would like to stay on, including our student presenters. But I will finish off the formal part of the meeting right now, which is to say, yeah, simply thank you all very much for speaking, and thank you to the University of Sussex for connecting with us and helping us organise this. We are going into our summer break for meetings now, so we will be back to 7 p.m. on the 8th of October, I believe, if anyone else wants to correct me on that. My dates aren't that good, but I think that's when we're back, and we will be hosting the prize winners from the University of Brighton, and if they're anywhere near as good as today's, I will be very happy with that. So thank you all very much for your time.